scientists, welcome to room 9 and happy almost Halloween. Aren't you so excited it's almost Halloween? Gosh, I feel like it came so quick. I sure am super ready. I have my cool unicorn hat on with my tutu and my unicorn tail. I am ready to go. I'm ready to enjoy this awesome Halloween and eat some yummy candy. I just love candy, especially chocolate. So I'm especially excited that you are here with me today, whether you have your cool outfit on or if you're just super excited to put it on tomorrow. I'm so happy you joined me today to learn about science. It's such an amazing subject. It's all around us, and I just love learning more and more about the world around us. So let's get started. My name is Mrs. Newby, and I teach at Flint Park Elementary School, which is in the school district of University City. And today I'm going to teach you about how humans think like plants. It's so amazing that we can look at nature and we can look at plants and look at what they're already doing, and we can just copy them to solve our problems. I want to be able to show you 3 different examples of how humans have already invented things because nature already does it. And hopefully by the end of this lesson, you can think like an engineer and especially think like a plant to solve different problems. Okay, so the very first example that I want to show you is probably something you've recently seen fall off of a tree. And it kind of falls in a cool way. Can you guess what it is? If you guessed helicopters, you are correct. These are such cool plants that just fall off of a tree. I just get so hooked and staring at it every time they fall because they just fall in such cool ways. So they're actually called maple fruits, and they come from maple plants, maple trees, and they fall kind of like in a spirally way. It's kind of neat. Now, one way that scientists have studied these maple fruits and how they're shaped and how they fall is by inventing a special type of drone that flies in the air that is very similar to this. And they actually call it a maple fruit drone. It's kind of cool. So they use the shape of this. I think they kind of put like the machine kind of where that seed actually is, and then the wing it looks very similar to this, and it just kind of like spins like that. And it's really little, so you can like fit it in a backpack. And it's kind of cool. If you see videos of how they test it out and fly it in the air, you'll see it looks almost exactly like one of these helicopters. So let me put this here, and I want to jot down how humans and engineers have used these to help us. So I want to put drone. And I'm sure there are so many other ways that scientists have used these plants to help them solve problems. But I think a small, like a mini drone especially, would be super cool to see. And it's kind of cool that they use these helicopters as an example to design the shape of it. Now the other one, I'm sure you have also seen in nature, and you probably get super annoyed by them because if you're going in the bushes or if you're in the woods, you come out of it, you have all of this just stuff, or like these little balls like stuck to you. Do you know what that's called? It's actually called Burr. So this is what they look like. They're so annoying sometimes, right? You just want to get them off of you, or they poke you everywhere, and you're just like, ow, ow, ow. And you have to take them off, and they're just everywhere. So scientists have actually used this annoying little plant that we think is just super frustrating to actually make something that we use all of the time now. Can you guess what it is? I don't know. I use it a lot in my classroom. Man, I don't know what I would do without it. You want me to tell you what it is? It's actually Velcro. It sticks together because scientists have used the materials that Burr kind of has to stick to our clothes and to ourselves to actually stick Velcro together. So it's kind of hard, see? You just gotta. So this part right here, like the super like smoother one, they actually they study Burr to figure out, well, how can I get two pieces of something to stick together? So we have kind of like a clothy side of Velcro, which probably is like our clothes. That's what, the Burr gets stuck to. And then they're like, okay, well, we need a different type of material that can stick to this cloth. So they invented this side of Velcro, and that's why we're able to now have Velcro. You probably have Velcro on your shoes, or maybe some coats or jackets you have Velcro on, or cool backpacks. Velcro is everywhere now, and we can thank Burr for our Velcro. It's kind of cool. So let's jot that down. Velcro. Whew. Now, the last example I have for you is not actually a plant, it's actually an animal, but the cool thing about that is that now we know that scientists also study animals, not only just to learn cool facts about them, but they study animals so that we can use things about them to help us. So this one right here actually comes in handy a lot for many, many people who really, really need this invention. So this animal is a bat. Now, if you've ever seen a bat in real person, they kind of scare me a little bit, but and this is perfect for Halloween time. Look at them kind of snoozing. It's kind of interesting that this picture is like in daytime. I've never seen a bat in daytime. Have you? I don't know. Usually I see like something flying up in the air like at night, and I'm like, oh, that's probably a bat. And it's like super little and super fast. But guess what's super interesting about bats? Now, one thing that I especially know about bats is that they hear very, very well, right? And they use something called echolocation. So when a sound happens and it hits the wall, it bounces back and it hits their ears. So then they know, oh, that's where my food is, or oh, there's a wall there. And sometimes they make squeaky noises so that their squeaks can bounce off of things so that they don't run into things at night, because it's super dark at night when they fly. So they need their ears to rely on so they don't run into things and they can find food easier. And they make that squeaky noise so that the noise can bounce off of the surfaces and they'll know how close they are at something. Well, scientists have studied bats and have studied how cool bats use sound to bounce off of walls, and they wanted to help people who are actually blind or have trouble seeing. Isn't that cool? Guess what a lot of blind people carry around with them? They carry around that cool cane, and at the very bottom of the cane is like this round ball. So what blind people are able to practice is they can actually hit the cane on the ground or just things around them, and they're able to hear much better the sound bouncing off of different surfaces so that they know how close they are at a wall or maybe a step that's in front of them so they don't trip over. So blind people and people who struggle really, really a lot with seeing rely on those canes in order to hear sound just like bats do. So they made sure to design that cane so it can make a special kind of noise and bounce back so those blind people can kind of train their ears to hear that. But we wouldn't have known that if we didn't study this cool animal, sometimes kind of scary, right? And know how they do it. So let's write that down. Cane for the blind. So I'm sure lots of people are super grateful for animals that have cool characteristics like echolocation. So it's so cool. So I want to be able to think, how can we think like a plant in order to solve a problem? So let's first think and study a plant. Okay, I want to be able to draw one and kind of think, oh, what are all the parts of a plant, right? Okay. Okay. see, I hope you guys have your cool notebooks ready to jot this stuff down, okay? So let me get my marker so we can draw a plant. So we have brown for a trunk. So let's draw that really quick first. So we're gonna draw a tree, okay? Because a tree is a pretty cool plant. It's a really big one too. So let's draw a giant trunk. Maybe we can have some grass in the bottom. There we go. That's some pretty grass, right? And then let's use the green again to make the big leaves, right? So let's go ahead and just whoosh, whoosh. It can be any tree you want. Maybe you can put a plant on there or some type of fruit. It can be some type of fruit tree. Do pumpkins grow on trees? No, maybe not pumpkins, but maybe apples or oranges, right? Okay, so let's label this really quick. So we call this a trunk for like grown trees, but whenever they're like baby trees, what are they called? Do you guys remember? Starts with an S. A stem. So I'm gonna put here trunk / stem. Okay? What else? You know what I forgot, silly me? Lots of plants actually have leaves. So I'm just gonna draw a few leaves here and there so we can see them. Do my leaves look silly? Yeah. But plants have leaves, right? That's an important thing that plants have. So let's go ahead and label one. I'll label this little guy leaf. What else? Oh, we also learned, silly me, we learned about fruits and the importance of fruits and even flowers in trees, right? Remember how the flower blooms and then the petals fall, and then after the petals fall, then the fruit actually grows in that place. So it's really important to have that. Let's see. I'm going to draw a flower here because we need that flower. That looks like a silly flower, doesn't it? And I'm gonna draw an apple here because this is going to be my little apple plant. Now in real life, there's probably way more apples and way more plants, right? But we're just labeling the important parts. So I'm gonna put fruit. Every plant has fruit. Sometimes we call them vegetables because we cook them like vegetables, but they're actually fruit because every plant grows fruit. And we have a flower. And that flower is super important because it gives us the seeds for more fruit and more plants. Are we missing anything? We have the stem, leaves, fruit, flower. Isn't there something like in the ground that we need? What? Oh, the roots. You are so right. Oh my goodness. We need those roots in the ground. Let's go ahead and draw some roots. And let's label it. Okay, so now we have all the parts. So now let's think, okay, how can we think like a plant? How can we think like this tree to solve a problem? Well, we have to understand what these parts do, right? So we've learned this before. We know that the flowers give us the seeds, right? They actually give us the fruit, and the fruit give us the other seeds. So after we open an apple up, there's more seeds that we can plant to make more apple trees. So we know what's important about those. We know that the leaves kind of like sunbathe, remember that? Like, to kind of get that food and that energy from the sun. It's kind of cool, right? So the leaves are super important for that. We know that the stem kind of acts like a straw. I wonder if scientists used what a stem does to invent straws. That would be an interesting to study. Interesting thing, huh? So like we like slurp it up, kind of like what the stem does. It actually gets the water from the roots and it brings it up to the plant, so the plant gets some water too. That would be super interesting. Well, what about the roots? What do the roots do? Oh yeah, they actually, so when it rains, they collect that water so that the stem can slurp it up. But another really important thing that stems or roots do is that they hold the plant in place. So if I were to push a tree or a plant, would it fall down? No, because those roots hold it in place. I wonder if we can use what a plant does to solve a problem. Are you ready to find out with me? I think I have an idea. Let's take a look. Okay, so in order to think like plants, especially to think like roots, I thought about houses. What if architects or different builders didn't think about how to hold houses in place and they just kind of plopped them on the ground and said, okay, enjoy. So I want to do an experiment to see what would really happen if architects didn't think like that. So I have cool houses here that I built. I got a red one and a blue one. So if I just plop them on the ground, here's the ground, it's nice and flat, and I don't dig, I don't do anything, I just plop them, bloop, there we go. Okay, ready to move in. And then a hurricane comes. What do you think is gonna happen? There's no roots, there's nothing holding them in the ground, so of course, the houses are just gonna fly back, right? Just gonna fall down. Let's find out. So I'm gonna be the big hurricane. You ready? 1, 2, 3. That didn't take much at all. They were completely destroyed. That would be the end of it, right? Ugh. But you know what's interesting about nature and trees is that it can teach architects something super important. So a special kind of tree, I love oak trees. They're really cool. They take so many years to even grow to be adult trees. And they're just really cool plants and trees. But a lot of the times, whenever they are planted next to other oak trees, they actually do something really cool to the roots. Not only do they grow the roots down in the ground to hold themselves in place, they actually interlock with one another. So you have these trees in a line, and if you look in the ground, which I know it's kind of hard to do, but if you're able to look in the ground, you will notice that these roots with all these other different trees are just interlocked with one another. So a lot of areas that experienced hurricanes, you'll notice that these giant, really old oak trees are still standing, even with all of this hard and strong winds. And scientists and even architects who help build houses and design houses have studied and figured out why, or even how are these trees able to withstand such strong winds? And they discovered that it's because they're interlocked in the ground. And they wanted to use that idea to be able to build houses in areas that experience lots of hurricanes so that they can kind of interlock or join houses together. So whenever hurricanes happen again, they're going to be less likely to get destroyed or less likely to fall over. So let's find out if that would be true. So here's my houses again. I'm thinking like a tree. I'm going to think like a root. And I'm gonna join these houses together, okay? So watch how I do this. So I have some zip tie, and I'm just gonna kind of like bring them. Here's the ground, I'm digging holes in the ground, doing all this construction. Here we go. Let's see, maybe I can do it like this. Think like a root. think like a root. Okay, here we go. So I'm just gonna kind of not only connect it to the ground, because trees have roots and they're already, you know, planted in the ground and they hold the place. So here I am going to build my houses, and I'm just going to lock them in the ground. But guess what? That's not going to be the end of it, because I want to be able to connect these houses to one another to see if that will solve the problem, just like trees have solved the problem for them. It's kind of cool how trees kind of take care of themselves, right? They know exactly what they need, and they do it for themselves so that they can survive. And it's even cooler that we can study how smart and clever plants are, and we can do just what they do. I'm almost done here, so let's go ahead and keep doing this. Okay, so they're planted in the ground. Let's go ahead and lock them in. Lockety lock. Lockety lock. And lock. One more. Oops, silly me. And as I'm doing this, you guys can also think about, well, how else can I think like a plant? What else do you think you can use or think of that plants already do that you can also do to solve just an everyday problem? Okay, so all my beautiful houses now are finally locked in place. So you notice here I use my zip tie and I just lock them in the ground, okay? So typically if a hurricane were to come, it probably would be a little bit harder to blow them down, right? But a lot of the times they might get pretty loose and a lot of their foundation still might kind of be a little wobbly. So if architects were to think like roots, they probably could use more like wiring or pipes or something, I'm not really sure because I'm not quite an architect, and connect the houses. So notice here, I'm just going to connect one house to another with another zip tie and kind of lock them together. Let's do that one and this one. Okay, so not only are they grounded in the ground, but now they're actually attached to one another. So now they're like super, super sturdy. Imagine having houses like that. If their houses are just connected and just kind of like interwoven like roots. Let's see what would happen. Okay, are you ready to huff and puff and blow with me? Here we go. 1, 2, 3. And we thought of the roots that they have and we grounded them with one another in the ground. So imagine if we had houses in a lot of those areas that have lots of hurricanes and just horrible weather sometimes. If we're able to lock those houses down, they could really, really protect these houses and keep them standing up for these people so that their homes aren't destroyed. Isn't that amazing? Oh, I just love trees. Man, we've learned so much about them. They give us so many cool resources for just everyday materials that we use, like fabric and like cotton and paper and just wood and things like that. And today we learned that they give us so much more because they give us knowledge. They give us information and just cool things about them that help them or help us make inventions and help engineers like you and me come up with solutions to problems that humans have. It's super cool. So I want to challenge you, and I want you to think of a problem that you may have, or maybe a family member, or just your community. What type of problem can you come up with? And then if you think like any type of plant, anything, can you use the knowledge of different plants to solve that problem? Because I can almost guarantee you that nature is probably already doing it. Man, I hope you have fun thinking about these things and studying up and learning so much more about plants because they give us so much knowledge. And I especially want to wish you a happy Halloween, and make sure that you're being safe, you're being careful, and stay healthy. Enjoy your week, and I'll see you next time. Bye.
Teaching in Room 9 is made possible with support of Bank of America, Dana Brown Charitable Trust, Emerson, and viewers like you.